Beach pneumatic transit. The beach pneumatic transit is the subway that New York almost had in 1870, built in secret beneath Broadway, across 58 consecutive nights. Alfred Ely Beach applied for permits to construct postal tubes. What he built instead was a 312-foot passenger tunnel, excavated by workers who wrapped wagon wheels in cloth and hauled dirt away under darkness. A 48-ton rotary blower forced a passenger car through the tunnel, the way a finger forces water through a garden hose. The station featured frescoes, upholstered chairs, a piano, and a goldfish pond, because Beach understood that fear of going underground was the real obstacle. Over 400,000 people paid 25 cents to ride it in its first year. Boss Tweed's grip on surface transit contracts killed every expansion permit. The tunnel was sealed and forgotten until 1912, when workers boring a new subway line broke through a wall and found the original car, the piano, and the station sitting intact in the dark. Aerotrain. The Aerotrain is the fastest air-cushioned vehicle ever built on land, and France destroyed it. Jean Bertin's machine rode on a 10-millimeter cushion of compressed air with no wheels, no rails, and no rolling resistance. On March 5, 1974, a prototype fitted with a jet turbofan reached 430.3 kilometers per hour, a world record that remains unbeaten 50 years later. A commercial line was signed and ready. The traditional French rail and steel industries lobbied the government with focused intensity. President Giscard d'Estaing canceled the program and redirected investment to the TGV. Jean Bertin died within months. 18 kilometers of elevated concrete guideway still stand in the fields outside Orleans, holding up nothing. The two remaining prototypes were destroyed in fires in 1991 and 1992. No cause was established for either fire. M497 Black Beetle. The M497 is the fastest train America ever built, and it cost $35,000 and 1 month of work. In 1966, engineer Don Wetzel bolted two surplus General Electric J-47 turbojet engines from B-36 bombers onto the roof of a standard rail car, tilted 5 degrees nose down so thrust would press the car onto the rails rather than lift it off. The aerodynamic nose cone was sketched by his wife based on what looked right to her eye. On July 23, 1966, on a dead-straight section of track in Ohio, the M497 reached 196 miles per hour and set an American rail speed record that stood for 8 years. It was nearly 2.5 times faster than the 79 miles per hour limit governing most American passenger rail. The New York Central merger sidelined the project within months. The jet engines were repurposed as a snowblower, which melted ice effectively and scattered track ballast in every direction, and was retired. The car was scrapped in 1984. America looked at 196 miles per hour and went back to 79. Benny Railplane. George Benny built a working version of the future in a Scottish field in 1930, watched it function perfectly, and spent the next 7 years going bankrupt trying to convince someone to care. The railplane hung from a single overhead rail, driven by electric air screws at each end, with no contact with the track below. The concept stacked fast passenger travel above slow freight, running over existing rail lines at a projected 150 miles per hour, using airspace above infrastructure that already existed. The 130-yard prototype in Milngavie, Scotland operated exactly as promised. The capital required for tower infrastructure across even a single commercial corridor was beyond what anyone would commit to a demonstration track in a field. Benny went bankrupt in 1937. The prototype rusted for 19 years and was sold for scrap in 1956. South Devon Atmospheric Railway. Isambard Kingdom Brunel's atmospheric railway was the fastest land transit on Earth in 1847, and it was destroyed by rats. The hills of South Devon exceeded gradients that contemporary steam locomotives could not manage, so Brunel removed the engine from the train entirely. A cast-iron pipe ran between the rails. Pumping stations evacuated the air ahead, and atmospheric pressure pushed the train from behind. On gradients that crippled steam engines, trains reached 70 miles per hour. The pipe required a continuous leather flap to remain airtight, treated with tallow to stay supple. Tallow is rendered animal fat. Rats ate the seals along the entire route, introducing air leaks that collapsed the vacuum the system depended on. The railway operated for 1 year before Brunel recommended abandonment. The total loss was £500,000. Advanced passenger train. British Rail's advanced passenger train solved one of the hardest problems in rail engineering, handed the solution to Italy, and bought it back 20 years later at full price. The West Coast Main Line's Victorian curves capped safe speeds at 100 miles per hour. The APT's answer was to make the train lean. Hydraulic actuators tilted passenger carriages 9 degrees inward through every curve, neutralizing the forces that would otherwise derail a train doing 150 miles per hour through geometry designed for something doing 60. The APT set a British rail record of 162.2 miles per hour in 1979. During a press demonstration in December 1981, the tilt system worked so well it created a sensory mismatch between what journalists felt and what they saw. Several felt nauseated. The tabloids called it the Queasy Rider. British Rail abandoned the program in 1986 and sold the tilting patents to Fiat, who refined them into the Pendolino. 2 decades later, British operators purchased Pendolinos from Italy to run on the exact line the APT was built for. Transrapid Munich. Germany spent 35 years developing a train that levitates 10 millimeters above its track at 500 kilometers per hour. Then canceled its first domestic commercial application over a cost argument resolved in a single afternoon. The Transrapid wraps around a concrete guideway and pulls itself upward, using electromagnetic force, adjusted 100,000 times per second to hold the gap at exactly 10 millimeters. No friction, no mechanical wear, almost no noise. The Munich airport line would have covered 40 kilometers in 10 minutes. Cost estimates rose from 1.85 billion euros in 2002 to above 3 billion by 2008. At a meeting in Berlin on March 27, 2008, federal and state governments canceled the project the same day. A 30-kilometer Transrapid line operates commercially in Shanghai, built using German technology and German components. In Germany, the Transrapid has never carried a single revenue passenger. HS2, Phase 2. High Speed 2 was announced as a complete high-speed spine, connecting London, Birmingham, Manchester, and Leeds. Phase 2, the northern extensions, was cancelled in October 2023 at a projected cost of £36 billion, the largest single infrastructure cancellation in British history. The track that has been built ends in a field in Staffordshire. At London Euston, the terminus was designed for 11 platforms, processing 18 trains per hour. The revised scheme delivers 6 platforms and roughly half that capacity from day one. Before a single Euston platform was built, £250 million was spent on design work that was discarded entirely. The £36 billion was repackaged as a roads and bus investment program. The United Kingdom remains one of the only major European economies without a functioning national high-speed rail network. The Victorian infrastructure HS2 was meant to replace is still running. Hyperloop. Hyperloop 1 raised $450 million, built 500 meters of test track in a Nevada desert, ran a pod to 240 miles per hour, and shut down permanently on December 31, 2023, having built 0 miles of commercial infrastructure. The physics of the concept are sound. A steel tube sealed to near vacuum, thousands of miles long, expands and contracts with temperature, crosses geologically active land, passes through dozens of regulatory jurisdictions, and must maintain integrity across every weld for decades. No commercially viable solution to those constraints exists at scale. The DevLoop test track in Nevada represents the entire physical legacy of 9 years of work and $450 million. The tube is still there. Nobody is using it for anything. Transatlantic Tunnel. The Transatlantic Tunnel has never been proposed by any government or funded by any institution, yet its specifications are known with reasonable precision. The concept connects New York to London through a submerged tunnel 3,400 miles long, held 50 meters below the ocean surface by 100,000 tethering cables, carrying a maglev train at 5,000 miles per hour through near total vacuum. Journey time is theoretically 54 minutes. The cost is estimated between $12 trillion and $20 trillion. The Mid-Atlantic Ridge crosses the proposed route directly, one of the most seismically active geological structures on the planet. The materials required to survive deep ocean currents, thermal expansion, and seismic movement across a century of service do not currently exist. It is studied and revisited every decade because it represents the logical conclusion of what trains are for. It remains a problem for a later civilization to solve.